Big decisions require research. So if your teenager is considering a decision as big as joining the military, they're doing their homework. You can too, by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
New on CuriosityStream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
This is SpaceTime Series 23, Episode 82, for broadcast on the 14th of August, 2020. Coming up on SpaceTime, a neutron star at the heart of Supernova 1987A. SpaceX Dragon completes its first mission carrying crew to the International Space Station. And the annual Perseids meteor shower among the highlights of the night skies on August Skywatch. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There's growing evidence that a neutron star was created from the explosion of Supernova 1987A. The event marked the explosive death of a spectral type B3 supergiant star called Sanderloop 69202, located on the outskirts of the Tarantula Nebula, some 168,000 light-years away in the Large Magellanic Cloud, a satellite dwarf galaxy orbiting the Milky Way. The progenitor star is estimated to have been around 20 times more massive than the Sun. Light from this supernova event reached Earth in February 1987, making it the closest observed supernova since the invention of the telescope and Kepler's supernova, which was visible from Earth in 1604. In fact, 1987A gave modern-day astronomers their first opportunity to study a nearby core collapse Type II supernova in unprecedented detail, in the process gleaning many new insights into stellar evolution. Based on the mass of the progenitor star, 1987A should have produced a super-dense compact stellar corpse called a neutron star. And the neutrino data suggested that a compact object did form at the star's core. However, more than 33 years later, astronomers are still trying to confirm its existence beyond doubt. That's because the center of the explosion is hidden, concealed in a thick cloud of cosmic dust. The supernova explosion that took place at the end of the star's life resulted in a huge amount of gas with temperatures of over 1 million degrees. But as the gas began to cool down quickly to below 0 degrees centigrade, some of it condensed into solid dust grains. The presence of this thick cloud of dust has long been the main explanation as to why the missing neutron star has not been observed. But many astronomers are skeptical about this, and they've begun questioning as to whether their understanding of stellar evolution is correct. Now, 2 teams of astronomers have made a compelling case in the 33-year-old mystery surrounding Supernova 1987A. The findings are based on observations by ALMA, the Atacama Large Millimeter Submillimeter Array Radio Telescope in Chile, and new theoretical follow-up studies providing fresh insight supporting the hypothesis that a young neutron star is hiding deep inside the supernova. Recent observations by ALMA provided the first indications of the missing neutron star after the explosion. Extremely high-resolution images are revealing a hot blob at the dusty core of 1987A, which is a lot brighter than its surroundings and matches the suspected location of the neutron star. One of the members of the team that discovered this blob, Kako Matsura from Cardiff University, says the team was surprised to see this warm blob made by a thick cloud of dust in the supernova remnant. It meant that something in the cloud's heating up all this dust and causing it to shine. That's why they suggested there could be a neutron star hiding inside the dust cloud. However, they've wondered about the brightness of this blob, which they think might even be a bit too bright to be a neutron star. And that's where Danny Page from the National Autonomous University in Mexico and colleagues have come in. They've published a new study showing how neutron stars could indeed shine that brightly if they're still very young. The study, reported in the Astrophysical Journal, strongly supports the suggestion made by the ALMA team that a neutron star is indeed powering the dust blob. In spite of the supreme complexity of a supernova explosion and the extreme conditions in the interior of a neutron star, the detection of a warm blob of dust is a confirmation of several predictions. And these include the location and temperature of the neutron star. Now, according to supernova computer models, the explosion has kicked away the neutron star from its birthplace with a speed of several hundred kilometers per second. And the blob's exactly at the place where the astronomers think the neutron star should be today. Also, the temperature of the neutron star, which is predicted to be around 5 million degrees Celsius, would provide more than enough energy to explain the brightness of the blob. Contrary to common expectations, the neutron star is not likely to be a pulsar. A pulsar's power depends on how fast it spins and on its magnetic field strength, both of which would need to have very finely tuned values to match the observations. While on the other hand, the thermal energy simply emitted by the hot surface of a young neutron star naturally fits in with the data. Also, the predictions of a supernova's neutrino signal match the subsequent observations, showing a sudden burst of neutrinos flooding the Earth before the light from the supernova arrived. Those neutrinos strongly suggest that a black hole never formed. Also, it seems difficult for a black hole to explain the observed brightness of the blob. So the observations all seem to support the idea that a hot neutron star is the most likely explanation. The neutron star is a 25-kilometre wide, extremely hot ball of ultra-dense matter. In fact, just a teaspoon of neutron star material would weigh billions of tons. And because it's only 33 years old, this would be the youngest neutron star ever found. The second youngest neutron star that we know of is located in the supernova remnant Cassiopeia A, which is some 330 years old. Of course, only a direct image of the neutron star will give definite proof that it exists. But for that, astronomers will need to wait a few more decades until the dust and gas in the supernova remnant becomes somewhat more transparent. This is SpaceTime. Still to come, SpaceX's Dragon completes its first mission, carrying crew to and from the International Space Station, and a stunning early morning launch for a Russian Proton rocket. All that and more still to come on SpaceTime.
Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at pepboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit pepboys.com to learn more.
Okay, let's take a break from our show for a word from our sponsor, The Great Courses Plus. You know, I love learning new things. It's what I thrive on. And because you listen to SpaceTime, I know that you love it too. And that's why, like me, you'll love The Great Courses Plus. It'll expand your curious mind, build up your skills, improve your memory and self-confidence. The list goes on. The Great Courses Plus is designed for the lifelong learner in all of us. It's a streaming service providing instant access to literally thousands of fascinating fact-based lectures across almost any topic imaginable. And it's all taught by world-leading experts and professors in their fields. You can explore topics like the aging brain, great trials of world history. You can even learn how to cook or play chess. And with the Great Courses Plus app, it's easy to watch or listen anytime, anywhere. And it's great for any age, even high school and college students. Now, one course you've got to check out is an Introduction to Astrophysics presented by Dr. Joshua Wynn, Professor of Astrophysical Sciences at Princeton University, New Jersey. And you won't even need to catch the scooter to get there. Now, I think this is a great introduction to the fascinating world of astrophysics. You'll find out why planets move in elliptical orbits, why stars shine, how to detect gravitational waves, the laws of gravity, what electromagnetism is all about. You'll learn about the strange world of quantum theory and much more. In fact, by the end of the 24 easy-to-digest lectures, you're going to feel a whole lot smarter. And there's a really handy course guide you can download as well, so you won't have to worry about taking notes. And with lockdowns returning, with the second wave of COVID-19 starting to make its presence felt, now is the perfect time to sign up for the Great Courses Plus. Now, as a SpaceTime listener, you can check out the Great Courses Plus for free. That's right, free access to their entire library. So, what do you got to lose? Don't wait any longer. Sign up today using our special URL. You can start your free trial at thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course, those URL details are available on our website and in the show notes. That's thegreatcoursesplus.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
The first ever privately operated manned orbital spaceflight has returned safely to Earth. NASA astronauts Robert Behnken and Douglas Hurley splashed down under parachutes aboard a SpaceX Crew Dragon 2 capsule in the warm waters of the Gulf of Mexico off the coast of Pensacola, Florida. The historic return was also the first splashdown by U.S. astronauts in 45 years.
Dragon SpaceX, deorbit sequence start.
Never copied.
The capsule, as it is preparing to deploy those initial parachutes, the drogue parachutes. Again, these parachutes help slow the vehicle down and help stabilize in preparation for main chute deployment. Right about now, the capsule is going about 400 miles per hour, decelerating quickly.
And standing by for drogue deploys.
Visual, 2 drogues out.
We do drogue. All right, so 2 of 2, the drogues now out. They're going to do their slowing and stabilizing of the Dragon spacecraft. They should be detaching in just a few moments, and then we'll see 4 parachutes, the main parachutes deployed. Dragon under drogues.
Drogue descent rate nominal.
The expected descent rate, the expected velocity under the drogues nominal. We're right at around 150 miles an hour and already dropping. Drogues now detach.
And there we have confirmation of deployment of the 4 main parachutes.
We are visual on 4 chutes out.
We are visual. 4 main parachutes deployed. 4 main.
So at this point, the main parachutes have deployed. They are inflating, continuing to slow Dragon down significantly. We are anticipating splashdown in just under 2 minutes and 30 seconds.
Yeah, we've already slowed the vehicle down to about 16 miles an hour. It's already less than a kilometer in altitude.
Main chute descent rate nominal, passing through 700 meters.
So at this point, Dragon has saved all propulsion systems on
600
board.
meters.
600 meters.
And we're 600 meters above the Gulf of Mexico.
Should be approximately 1:30 from splashdown.
Mission control team here in Hawthorne has reported the precise landing coordinates to the recovery team. They are standing by, ready to go get our space dads.
100 meters. Just passed about 300 meters. 1 minute till splashdown. 200 meters. We are braced for splashdown.
Copy, brace for splashdown.
So there we heard Bob and Doug reporting that they are bracing for a splashdown as we're now just about 20 meters off the ocean.
Splashdown.
Confirmation for splashdown.
SpaceX copies and concurs. We see splashdown and mains cut.
Dragon Endeavour has returned home. NASA astronauts
and Endeavour, on behalf of the SpaceX and NASA teams, welcome back to planet Earth, and thanks for flying SpaceX.
It was truly our honor and privilege to fly in flight of the Crew Dragon and Endeavour. Congrats, everybody. That's all good. And we're into section of 4.800.
Thanks for those words, Doug, and we copy that you are into 4.800.
So great news all around there. Our space dads are back on Earth after a 19-hour return journey from space.
Their Crew Dragon 2 capsule had launched from Pad 39A at the Cape Canaveral Air Force Base in Florida over 2 months earlier on May the 30th aboard a Falcon 9 rocket on a test flight to the International Space Station. The mission marked the first manned orbital spaceflight from American soil since the return of the Space Shuttle Atlantis on STS-135 way back on July the 21st, 2011, marking the end of NASA's futuristic Space Shuttle program. Since then, all American astronauts have relied on Russian Soyuz rockets to reach the International Space Station. And that ride hasn't been cheap, at an average price of around $80 million per seat. During their 2-month stay on station, Behnken and Hurley joined in with the Expedition 63 crew, performing more than 100 hours of scientific experiments. Ben can also took part in 4 spacewalks with Expedition 63 commander and fellow NASA astronaut Chris Cassidy. The pair upgraded 2 power channels on the far starboard truss side, installing new lithium-ion batteries, routing power and Ethernet cables, removing equipment used for ground processing of the station's solar arrays prior to launch, installing a protective storage unit for robotic operations, and removing shields and covers in preparation for the installation later this year of a new commercial airlock. The Demo 2 mission was the latest test under NASA's Commercial Crew Program, which will see private operators SpaceX and Boeing take over the transfer of American crew to the International Space Station, thereby allowing NASA to focus on deep space missions using Orion spacecraft, flying crew to the Moon and ultimately onto Mars. NASA already contracts private operators SpaceX, Northrop Grumman and also soon Blue Origin to transport cargo to the space station. Meanwhile, Boeing has confirmed that its CST-100 Starliner Commercial Crew Program capsule will not be undertaking a manned spaceflight before next year at the earliest. Instead, they'll carry out at least one more orbital test flight without astronauts, possibly in October or November. The decision follows ongoing software problems and other technical issues which plagued the spacecraft's first orbital test flight back in December 2019, preventing Starliner from reaching the space station. This is SpaceTime. Still to come, a stunning early morning launch for a Russian Proton rocket, and the annual Perseids meteor shower among the highlights of the night skies on August Skywatch. All that and more coming up on SpaceTime. A Russian Proton rocket has carried 2 new telecommunications satellites into orbit in a spectacular nighttime launch. The 58-metre-tall Proton M rocket, equipped with the Breeze M upper stage, carried the Russian satellite communications company Express-80 and Express-103 spacecraft into geostationary transfer orbits from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The launch has been postponed by a day due to last-minute technical glitches. The Russian space agency Roscosmos says the Express-80 was successfully deployed 17 hours and 59 minutes after liftoff, with Express-103 deployed 17 minutes later. The satellites have now commenced a lengthy 160-day maneuver using their electric ion thrusters to reach their final geostationary orbital positions. Once in place, Express-80 and Express-103 will provide fixed mobile data services, digital TV, satellite radio broadcasting, and high-speed internet access for the next 15 years. Both satellites are assembled in Russia using European Thales Alenia Space Express-1000 bus designs. The 2,110kg Express-80 payload includes 16 C-band and 20 Ku-band transponders covering Russian territories, with a further 2 L-band transponders providing global coverage. Meanwhile, the 2,280kg Express-103 satellite will cover Russian and Southeastern Asiatic territories using 16 C-band and 20 Ku-band transponders, as well as a single L-band transponder providing global coverage. This is SpaceTime.
Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at petboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit petboys.com to learn more.
And time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month in the original 10-month Roman calendar under Romulus in 753 BCE. That was when the year started in March. It only became the 8th month when January and February were added to the year before March. Then in the year 8 BCE, the month was renamed in honour of the Roman statesman and military leader Augustus, who had achieved several of his great triumphs, including the conquest of Egypt, during this month. The constellation Scorpius the Scorpion is high overhead, covering almost a third of the August night skies. And by far the most noticeable star in Scorpius is the red supergiant Antares, marking the heart of the Scorpion. Located some 470 light-years away, Antares means rival of Mars, and when they're close together in the sky, they certainly do look very similar. Antares, or Alpha Scorpii, has some 12.4 times the mass and some 450 times the diameter of our Sun, and it's one of the largest known stars in the universe. In fact, were it placed where our Sun is at the centre of our solar system, Antares would engulf all the inner planets, Mercury, Venus, Earth and Mars, with its outer surface reaching almost as far as the orbit of Jupiter. Antares also has a companion star, Antares B, a massive spectral type B blue-white star, at least 7.2 times the mass and 5.2 times the radius of our Sun. It's located about 224 astronomical units from the primary star. An astronomical unit is the average distance between the Earth and the Sun, roughly 150 million kilometres, or 8.3 light minutes. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and other characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars, followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun is by the way, spectral type K orange stars, and the coolest and least massive stars known, also the most common, are spectral type M red stars. Each spectral classification can further be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then a Roman numeral to represent luminosity. Now, putting that all together, that means our Sun is classified as a G2V, or if you prefer G25, yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit in a category between the largest planets, which are around 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which were not comets, which Messier therefore wasn't interested in, so he listed them so he didn't waste his time looking at them. Other astronomers have since added further objects to the list, bringing the total catalogue up to more than 110. Located some 7,000 light-years away, M4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which were all originally born at the same time in the same stellar nursery. Globular clusters are usually fairly ancient, some as old as galaxies, dating back around 12 billion years. Located just below the sting of Scorpius are the open star clusters M7 and M6. The nearer of the pair, M7, is about 800 light-years away, while M6 is a more distant 2,000 light-years. Open star clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and therefore more prone to drift away over time. Another open star cluster in Scorpius is NGC 6231, located 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of high-luminosity supergiant stars, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayets are extremely luminous evolved stars nearing the end of their lives. Having run out of hydrogen for core fusion, Wolf-Rayet stars are no longer on the main sequence and are fusing progressively heavier and heavier elements in their cores, generating powerful stellar winds and surface temperatures of up to 200,000 degrees. That compares to the Sun's surface temperature of about 5,800 degrees Celsius. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Now, as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, some 27,000 light-years away. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, which is big enough to be visible with the unaided eye. Located some 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky around which the planets orbit the Sun. M22 contains over 70,000 stars, covering an area of 100 light-years. It also contains at least 2 black holes, and is one of just a handful of globular clusters known to contain a planetary nebula, the puffed-off outer gaseous envelope of a dead Sun-like star. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation of Ophiuchus, the serpent bearer, often portrayed as a snake coiled around a man. In Greek mythology, it is Ophiuchus who raises Orion from the dead after he is bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard's star. Barnard's star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located 5.9 light-years away, Barnard's star is a spectral type M red dwarf, with only around 0.144 times the mass of our Sun. At between 7 and 12 billion years of age, Barnard's star is considerably older than the Sun, which is 4.6 billion years old, and it might even be among the oldest stars in the Milky Way galaxy. Barnard's star has lost a great deal of its rotational energy, and the periodic slight changes in its brightness indicates that it's rotating only once every 130 days. Given its age, Barnard's star was long assumed to be quiescent in terms of its stellar activity. But then in 1998, astronomers observed an intense stellar flare, indicating Barnard's star is a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness for a few minutes. It's believed that the flares on flare stars are analogous to solar flares on the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. Now, Libra also represents the claws of Scorpius in Greek mythology. However, the Romans considered Libra distinct from Scorpius, and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. 2,000 years ago, when Rome was in its prime, the Sun moved into Libra at the time of the September equinox. But due to precession, as Earth's spin axis wobbles in direction, this point in time has now moved to the adjoining constellation of Virgo. Now, looking to the south and towards the constellation Southern Cross, you'll see the constellation Centaurus, another half-man, half-horse mythical beast. According to mythology, Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars of the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star Beta Centauri lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. This globular cluster has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, at least 12 billion years old, and it contains many so-called population 2 stars. These were the second generation of stars to have formed in the universe, and are thought to have been created directly out of the remains of the very first stars to shine. The stars at the core of Omega Centauri are so crowded that they're estimated to average only 0.1 light-years in separation from each other. Now, that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Close to Omega Centauri is the giant lenticular galaxy NGC 5128, Centaurus A, which we see as looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a long time before the bright lights of a modern city would make such discoveries impossible. Located some 13 million light-years away, Centaurus A is home to one of the strongest radio sources in the sky, and is thought to be the result of a merger between 2 galaxies, one elliptical, the other spiral. It's easy to spot from your backyard using a pair of binoculars, but you'll need to use a telescope in order to make out its spectacular dust lanes. August is also the time for the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through our solar system. As the name suggests, the Perseids radiant, that's the point in the sky from which the meteors appear to originate, is in the constellation Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're most active between July the 17th and August the 24th, with the peak occurring right about now, with about 60 meteors per hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of more than 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere sky watchers, you need to look to the north because the radiant is below the northern horizon. And now with the rest of the August night skies, here's Jonathan Nally, editor of Australian Sky and Telescope magazine.
Well, g'day, Stuart. Well, yeah, it's winter still here in Australia, but we're heading towards spring, so the skies are changing a little bit. We've still got all the winter constellations around, which is really good because we have good constellations in our southern winter. Even though it's cold and it's winter and everything, we have good clear skies generally and lots of good things to see up there in the sky. And winter skies are dominated by the Milky Way for us down in the southern latitudes. You've got the centre of the galaxy up there, nice and high, lots of great stuff to see. Milky Way stretching right across the sky from northeast to southwest in the early part of the evening or the mid-evening when you'll be out doing some stargazing. And so you've got Sagittarius up there pretty much directly overhead for people who are at the latitude of Sydney, whatever that equates to in Africa and in South America or across the Pacific. And for all sorts of reasons, the galactic centre is a real focus of attention for astronomers because it's got this big black hole in the middle of it, which they're really interested in. And there's a great density of stars also between us and the galactic centre, so there's plenty of things to study. Our friends in the northern half of the planet don't really get a good view of Sagittarius because it's quite low on the horizon for most of them. And in fact, people who live in the far north of the northern hemisphere, you don't see Sagittarius at all, really. So we're quite lucky down here. We've got the Southern Cross, as usual. It's down there in the southwest, lying on its side now as the year has gone on. It's located within the band of the Milky Way, actually, the Southern Cross constellation, and stretching northwards from it along the line of the Milky Way. You've got these other famous, interesting constellations. You've got Centaurus, which is tremendous, and you've got Scorpius, Sagittarius, we've mentioned, and Scutum. Scutum is a constellation a lot of people haven't heard of before, but it's been there all the time. It's right next to Sagittarius, and it has some really nice deep sky objects. Deep sky objects are what astronomers call things like star clusters and nebulae, and if they're beyond our galaxy, other galaxies are also classed as deep sky objects. Things a long, long way away from our solar system. Mm-hmm. So this constellation, Scutum, it's actually named after an Italian scooter, would you believe it or not? But not the kind of scooter that cool people ride around on and, take the sunglasses off and look really...
Is there such a thing as a cool scooter?
A cool scooter? Well, I think...
Or is that more of a philosophical than an astronomical question?
That's right. But what's the point of rhetorical questions anyway? That's what I want to know. But no, it's not one of those sort of scooters. It's named after a scooter, Scuta, which is a kind of ancient Roman shield, and the constellation Scutum is the constellation of a shield. Okay, I don't know. It's one of those join the dots fairs where they join some dots up at the start.
Oh, look, a Vespa.
That's right, a Vespa. Okay. So if you're out there stargazing for long enough, if you stay out all night as the night goes on and the Earth turns, you'll notice that the sky changes because our perspective is changing, and the Milky Way, which was stretching from northeast to southwest, sort of goes in the other half of the sky now. And by the time you get into the early morning hours, you'll find that the Milky Way has sort of disappeared because instead of seeing half of it across the top of the sky, you now see it all the way around the horizon if you've got a good clear horizon and dark skies and no light pollution and all that sort of thing and no clouds. So it's funny because the Milky Way just seems to disappear. If you go out in the evening, you think, oh, there's the Milky Way, and you go out like early morning if you're up at about 5 o'clock or something. You think, where's the Milky Way gone? Still there. It's just that the Earth has turned, so our perspective looks a little bit different. Now to the planets. Mercury's pretty much out of view this month, I have to say, unfortunately, if you have been trying to spot Mercury. At the start of August, it's too low down in the eastern dawn sky to be easily seen. It's in the glare of the sun coming up. By the end of the month, it'll have swung around to the evening twilight sky out in the west, but again, far too low, really, to be easily spotted. People who know exactly what to look for can find it. If they've got a good clear horizon, hills and things, they get in the way then. you might not be able to see it because it will be very low on the horizon. So anyway, give Mercury a miss for August. If you are an early morning person, look out to the east around 4 o'clock and you'll see Venus coming up. Beautiful, big, bright. You can't miss it. It's the biggest and
brightest thing in the sky.
Yeah, other than the moon and the sun, of course. So it really looks wonderful, particularly when it's down low on the horizon and coming up and you follow it up. It's just beautiful. For evening stargazers, we've got Mars. Mars is coming up over the eastern horizon about 11 p.m. at the start of the month, slowly becoming brighter as the weeks pass, and that's because it's slowly getting closer to us, or we're slowly getting closer to it, or both, because we're heading towards closest approach in early October. Mars is pretty easy to spot as well. It's a medium brightness. It looks like a star, but it's a planet. But it's of a medium brightness, and it's got an orangey-red colour. And, it stands out quite nicely. But the two main planets to look for this month are Jupiter and Saturn, and you can't miss them. Both of them are shining big and bright and bold in the evening sky out there to the east. Honestly, you simply cannot miss them. They're quite close together too, which makes them easier to spot. Jupiter is the one above, and Saturn is the one below. Jupiter's a bit brighter, Saturn's a bit dimmer. And have a look on August the 29th. Write this down in your calendar or something. If you've got clear skies, go out August 29th because you'll see Jupiter and Saturn with the moon right in the middle of them. So they'll all be in a row. Jupiter, Moon and Saturn. It really should be something to see.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
'Tis the season to change your tires at Pep Boys. When it comes to holiday travel prep, your local Pep Boys has you covered. Buy 3 select tires and get the 4th one free instantly. Pep Boys offers online booking, text alerts to track your service, and mobile payments to pay on the go to get you back on the road safely. Make an appointment at pepboys.com and don't miss out on these incredible deals. Offer valid through November 30th. Requires installation and additional fees. See store for details or visit pepboys.com to learn more.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.